Hey guys, so let's discuss new topic from system design, which is called rate limiting. Okay, so in rate limiting, so it's like restricting how many requests a user can make in a given time window. So for example, we'll come on this theory part later. So let me go to the notepad. Okay, and in edit mode. Okay, so let's say you have one user here. Okay, and this is the server load balancer, and then this is the server. Okay, so user is sending request, and the thing is that you cannot limit users, right? User can be anything and they can send any request, any number of requests. So the problem is for your servers. Okay, you have a limited resources like CPU, memory, database connections. So if you are getting millions of requests per second, right, means some bots or spammer are spamming, and then they are sending 1000 requests per second, then your system will crash, correct? So in rate limiting, you limit the number of requests a user can send. Okay, so now for example, if I take the example, then the example is like maximum 100 requests per second user can send. Okay, user can send these many requests, and then maximum 5 logins per minute user can do. Okay, if it is beyond that, if it cross this number, then you just block the user. Okay, block the user to send the more request for particular number for particular time. Okay, now why we required rate limiting? So we will discuss here a few reasons why you required it. Okay, so the first one is prevent API abuse. Okay, prevent API abuse. So this is what I just described. So let's say you have one API send underscore OTP. Okay, slash send underscore OTP. This is the API you have. So if you call this API, then user will get OTP on his mobile or any other device, right? So what if this user is clicking it again and again? Okay, if he is making request to send OTP, so let's say he is using bots. Okay, now we have a bots AI generated thing, and then bots or spam. Okay, using that, if he try to send 1000 requests or 1 million requests per second, then in that case, so your API, your server will go down, right? And so what is the solution? So solution will be that for per second user can send n number of requests. That's it, like 3 requests, 5 requests per second. Okay, and then if it cross that number, then you just block user for some time, and then after some time he can again send the request. Okay, but again maximum 3 or 5, the number you have decided. Now the second one is prevent DDoS attack. Okay, now what is DDoS attack? So like let's say 1000 machines simultaneously sending request to your server. Okay, so now like 1000, they have multiple machines, and then they're sending 1000 machines are sending at the same time, right? Then in that case also your server is getting lots of requests at particular time. Okay, so that is the DDoS attack. So to prevent this also, we use this rate limiting. Okay, now the third one is prevent resources. Okay, prevent resource exhaustion. Okay, so prevent resource exhaustion. So I told you that you have a limited number of CPU, memory, okay, DB connections. So if someone is sending 10,000 requests per second, okay, then your resources will get exhausted, and your system will slow down or crash. Okay, now the fourth one is why we are, so here we are discussing why we required rate limiting. Okay, the fourth one is ensure fair usage. Okay, now how? Like for example, you can send 1000 requests per second. Let's say you have decided this limit, and per second your system can can process 1000 requests. Okay, now you have user 1 or user A, he is sending 900 requests per second, and then you have a user B, he is sending 10 requests per second. So what is the result? User B will suffer, right? Because user A has sent 900 requests per second. So this is not the fair usage of resources, correct? So that is also we prevent using this. Now the next one is ensure system stability. Okay, so now let's say there is a sudden spike, okay, in a request during the let's say sale, okay, Amazon sale or somewhere, someday there is a sudden spike in the system. So and your generally you get the 1000 requests per second, but now you are getting 50k requests per second. Okay, so in that case also you will have a server crash, okay, or cascading failure. One service will fail, then it will fail again, different dependent services. Okay, so that case is also there. Now what is the sixth one? Sixth one is it will improve performance. Okay, it will improve performance. So how? So see, you know that if there is a less load, okay, on a system, then it means that faster response. Okay, faster response. So instead of processing 10,000 requests per second, you process 2,000 requests per second, right? 2,000 requests per second. So you will get and other you will block. So you will get a faster response for this less number of requests. So these all 6 things are there that which is saying us that why we need to use rate limiting. Now let me remove this and let's talk that where you should implement rate limiting. Okay, so you have a few places like client side you can implement it, okay, server side you can implement it, or the third one is API gateway side you will implement it. So where will you implement? So let's say this is your client, okay, and this is your client machine. Okay, this is your client machine. Now here you have a API gateway. Okay, API gateway, and here you have your services, okay, microservice 1, microservice 2, microservice 3, and somewhere here you have a database and cache. We don't need cache right now. Okay, so either you can implement it on client side. Okay, client side means how? In a browser, JavaScript, okay, means UI side, or you can implement it at server side. So server side means inside your code, backend code, like Python, Node.js, Java. Okay, and the third one is you can implement it on API gateway side. So see, if you implement it on the client side, then this is weak. Why weak? Because spammer can remove that code, okay, JavaScript code, and then will send the request, or they can send request using Postman, right, or some script. So this is not good actually, right? Here you can do one thing, like for the user experience you can add, like if user will click button multiple times, okay, so the button should be disabled after particular number of times. So you can use that, but it will be used for the better UX experience, okay, and not for the security. The second thing is business side. Okay, business side means your Java backend side. So backend side, it is strong, it is good, okay, because they don't have access for your code, so this one is good. But here your services will have a load, and then if you implement this rate limiting for each service, then there will be a complexity in the code, right? Then the third one is API gateway, and this is the best place to implement rate limiting. Okay, why? Because before reaching to server itself, backend itself, he will just check here and then reject the request itself. So this is the best place to implement your rate limiting. Okay, now so you have some API gateway like Kong or NGINX. Okay, so just implement there this rate limiting. Now the next thing we will talk about rate limiting algorithm. Okay, so in rate limiting algorithm we have a 5 rate limiting algorithm. So before moving to those rate limiting algorithm, let's check theory part. Okay, till now what we have discussed, let's check that much and then we will move forward. So let me go there. So let's come at the starting. Okay, so whatever we discussed, let's check that in a structured format. Have you ever wondered how big application like WhatsApp, Instagram, Amazon prevent spam or API abuse or server overload? Okay, that's where rate limiting comes in. What is rate limiting? So rate limiting is restricting how many requests a user or a client can make in a given time window. Example, maximum 100 requests per minute per user, or maximum 5 login attempts per minute. Okay, why rate limiting? So this one we have already discussed, like preventing API abuse. Okay, just go through this document. I'll share the link of the document in the description section. Okay, and we'll pin that comment. So I do this for every video, so you can check the document from there. Then prevent DDoS. Okay, so we have discussed 6 points here. Prevent resource exhaustion, ensure fair usage, and ensure system stability, improve performance. Okay, then where to implement rate limiting, this one is also we have discussed client side. Okay, so client side, this happens in the front end or a browser using JavaScript. How it works: limit request using UI logic, like disabling a button after a few clicks. So what is the problem here? Easily bypassed. Okay, so user can modify JavaScript and attackers can send requests directly using tools like Postman or scripts. So what is the verdict here? Useful only for basic UX control, not security. Now server side, so this is implemented inside your backend like Node.js, Java, Python services. How it works? So it tracks request per user, IP or API key. See, you will have 3 options. Okay, either per user using user ID. Okay, you can check that this request is coming from which user ID. The second one is IP address, from which machine it is coming. But if you take on the IP address, so they can create multiple machines, okay, of different IPs, and then they can send requests from there. So the best thing is you combine these things like user ID plus IP address. So you combine these things to check. Then API key. Okay, so that is also you can track request on the basis of these points. Then block or slow down when limit are exceeded. Okay, either you can directly block them, or slow down means just add some delay and send the response. Now advantage: harder to bypass because they don't have access for the code, so they cannot bypass it. Can apply logic per user, role or endpoint. And then more secure than client side. But what is the drawback here? Logic is distributed. If you have many services, can increase backend complexity. Okay, now the third one is API gateway, which is the best way. Implement at the entry point of your system using tools like Kong and nginx. How it works? So all requests pass through the gateway. Rate limit are enforced before reaching backend service. What is the advantage here? Centralized control. Okay, one place to manage limit. Now here you can change anything. You can change rule for rate limiting. Okay, any rule, like how many requests you need to check and all. So that number you can change at one place only. Okay, this kind of configuration you can do. So this is centralized control. Protect all backend services automatically. Reduce load on your server. Okay, now easy to configure global rules per IP, API key, user, etc. Now example, limit 100 requests per minute per user. So gateway blocks access request instantly. Okay, more than that it will just block it. So simple takeaway: client side for user experience, server side for business logic, and API gateway for security and scalability. Now let's talk about rate limiting. Okay, so now you have a rate limiting algorithm, and let's talk directly. Let's jump onto, you have 5 rate limiting algorithm. Okay, and we will discuss all 5. So let's jump on the token bucket or leaky bucket. Okay, let's jump on the token bucket. So here you can see you have one let me take this. Okay, you have one token bucket. Okay, you have a token bucket which can have, let's say, 1 2 3 4 5 6, so 6 tokens, which can have 6 tokens per minute. Means per minute he can give this token 6 request only. Okay, he can serve 6 requests. And now you have new tokens, but every minute you can add new tokens, but the rate of those new tokens is 3 tokens per minute. Means this request, bucket can have maximum 1 2 3 4 5 6 tokens. Okay, 6 tokens, and per minute, refiller, let's say this is the refiller can refill 3 tokens. Okay, so now let's say at first second, here it is saying that add tokens to the bucket at a uniform rate. Means if it is 3 token, then in 1 second it can give 3 tokens only. Okay, so currently, let's say at first second, okay, first second he has given, he has refilled 3 tokens here in the bucket, and 3 already were there. So in bucket you have total 6 tokens, and first second refiller already has sent the tokens to this bucket. Now incoming request came, okay, and let's say 7 users came first time. So now you have only 6 tokens here. Okay, so if tokens are available, it will forward request to processing the system. Okay, so yeah, for initial 6 users he will give this tokens. Okay, for per request he will give 1 token, and then for 7th user he will drop the request because he doesn't have token at that particular moment. Now second will come. Okay, second 2 will come. Now again refiller will refill 3 tokens in the bucket. So now bucket has 3 tokens. Now if you're getting new request, then it will serve that request, but the earlier one he has dropped it. Okay, because he doesn't have that much token. So this was related to token bucket, and which is very important. Okay, so tokens are added at fixed rate, like through refiller. Okay, and how it works, bucket has capacity 100 tokens, like in our case it was 6. Each request consume 1 token, and token refill over the time. Means per second you can add tokens in the bucket. Now what is the pros here? Allow burst traffic. So for example, you have 6 tokens and you suddenly get the 6th request, so it will allow it. Okay, he doesn't have any problem until and unless he has a token. Smooth rate control. So here the control is pretty much okay, right? If let's say someone has a spammer has sent 1000 requests, then he will only cater first 6 requests, and other he will just reject it. Okay, so now the next one is leaky bucket. So what is the leaky bucket? Now here request process at the constant rate. So let's say this is, here also you have a bucket. Okay, but in a bucket you will have this in the bottom you will have one hole. Okay, from where at the particular rate the tokens are just going. Okay, so for example, bucket size is 40, so at max 40 tokens can we can store in a bucket, but one by one the token is coming. So like this will solve your burst traffic problem. Okay, so suddenly if 6 request is coming, so it will just give token with its own speed, right? So he request has to wait for some time. If bucket is full, then he will send code 429 is for too much request. Okay, like lots of too much request or lots of traffic came, so it will just return this error code 429. So now let's see the theory. Request process at constant rate. Okay, incoming requests go into queue, process steadily, and then smooth traffic prevent spikes, so you will not have a burst traffic here. Now the third one is, let's talk about the third one, which is your fixed window counter. Okay, now here you will have a window. So for example, at 1 second, first second, okay, let's say the capacity for each window is 3, means maximum he can process 3 requests only. Okay, and so let's say this is the first second. Okay, you got 3 and 3 6 requests. Okay, so 6 requests. So initial 3 though he has consumed it. Okay, but last three he has dropped it, because for 1 second the capacity is 3, he can process 3 requests only. Now second 2 came. Okay, second to third, now again he got the 4 requests, but he can consume only 3, and 1 he will drop. because the capacity is 3. Okay, now the third second, again 2 requests came and he has consumed it because it is lesser than the counter or the capacity, right? But here, can you see one problem here on the boundary means, let's say this is the boundary, okay, where the second 2 is completing and second 3 is starting, and here how many requests he has processed during this time. Let's say this is 2.5 and this is 3.5, so at the end this is 1 second only, right? So in 1 second he has processed 3 plus 2, 5 requests. But what is our algorithm? It is capacity equal to 3. In 1 second he can process 3 requests only, and this is also 1 second, right? 2.5 to 3.5. So here he is processing 5 requests. In fact, he can process 6 also, right? 3 plus 3. So this is the problem with this fixed size window. Now let's check the theory part. Okay, so fixed window counter count request in fixed window, like for example 1 minute or 1 second. Example, 100 requests per minute is allowed. For us it was 3 per second. Reset counter every minute. Okay, then your capacity will get reset for next minute or next second. So what is the problem? Burst issue at boundary. So boundary, we have seen that issue, right? Now for 59 second, let's say 100 request is coming, and for first second 100 request again will come. So 200 request he has processed, right? That is the problem. In 2 seconds 200 requests. So that is wrong, right? That's not our algorithm. So that's why, to solve this problem, we have the another algorithm which is called sliding window log. So here he just maintain one log, means request with that timestamp. Okay, so for example he will store. So for example, at this, let's say 10:42, okay, 3 requests came and the capacity is 3 only, so he can process this 3 requests. Okay, now at time, let's say this is 10:42.5, okay, and here one more request came. Okay, one more request came, so he cannot process this request. He will check the last window as well. Okay, for example, I'll tell you. Let's jump to the theory part first. Sliding window, store timestamp with each request. Okay, remove old timestamp and count request in last n seconds. So what is the pros? Accurate, and cons, high memory usage, because he is doing this extra processing, so high memory usage. So what he will do, let's say this is from 10:42 to 10:43, you have 1 second, which is one window. Okay, but now here you can see that he is tracking, and maximum he can process 3 requests, but here he is tracking this last window, means last 1 second window. If 3 requests are coming here, so he will check in last 1 second, okay, how many requests came. So he will check 4, so in that 4 he will reject this one. So this is called sliding window with log. Now the fifth one is, what is the fifth one? Fifth one is the combination of fixed window and sliding window log, which is called sliding window counter. Okay, so now here he will have a fixed window, but he will have a counter as well. So combined fixed and sliding window keeps count of current and previous window. Okay, now he will keep the current and previous window count and weighted calculation. Okay, pros, better accuracy, less memory. So here you can see that the limit is 10. Okay, and then this is the window 41 to 42, 42 to 43. Okay, now here if limit is 10, so in first second you got 2, 4, 6, 7 requests, so he will process it. That is not an issue, because at 1 second he can process 10 requests. Okay, now second 2, this 10 request got processed, and then this 11th one will get dropped. Now the third one, this 10 request will get processed, and then this 4 will get drop off. Okay, why? Because it is checking the previous counter also, right? That how many requests has been processed previously. So this was related to sliding window counter, okay, which is the combination of first two. So this was about the algorithm, rate limiting algorithm. Now let's jump onto the next topic, which is called common problem and solution. Okay, so what is the common problem you face when you design a rate limiting algorithms? So let's jump to the again um, theory part. Okay, or let me go to the notepad. So here, okay, what is the first problem? The first problem is race condition. If you're if you wanted to, let's say you wanted to design rate limiting, so the first problem will be your race condition. What is race condition? So let's say multiple request update same counter. Okay, so you have only one counter, and at the t time you got multiple requests simultaneously. Okay, at the same time only you got 3 requests, so all 3 will and the counter value is 2, so all 3 at the same time will change the value of this counter 2 to 3, right? But here you can see that this is the problem, because ideally it should be 2 plus 3, which is 5, but currently it is 3 only. Okay, because every request has changed the value of counter at a particular time, at the same time. So this is the problem. Okay, this is the race condition. So how you can remove this using the atomic operations. Okay, so like in Redis we do that atomic operation. This counter variable should be of atomic int type, let's say, right? Then this problem will get resolved. Now the second problem is distributed system issue. System issue. So what is distributed system issue? Let's say you have a multiple servers. Okay, and you will implement rate limiting algorithm in multiple servers. So multiple servers will have its own counter variable, right? So this server 1, okay, will have counter variable, let's say 2. Server 2 will have counter variable which is 3 for the same request. Okay, same API endpoints, let's say. Now these two are not in sync, right? We can send like 3 requests only per second. We can process 3 requests per second, but server 1 has the counter 2, server 2 has a counter 3, so which is correct for them. But if you check the combined one is 2 plus 3, so we are processing 5 requests, so that is wrong, right? So they are not in sync. So this is called the distributed system problem issue. And what is the solution for this? So you need to use centralized cache. So one cache will be here, okay, and you store your counter variable, and then this both server will update the counter variable value. Okay, so this is the solution for this distributed system issue. Now the third one is rate limit bypass. Third one is rate limit bypass. Now what is rate limit bypass? Let's say if rate limiting you have done on IP address, I have already told you cannot do only for IP address. You should take the combination of user ID or IP address, because the spammer can create thousands of IP addresses, okay, and then they can send requests from there. So rate limiting bypass is if rate limiter done on IP address only, then user can trick system using different IP addresses. Okay, solution: don't rely on IP address, use combination of user ID plus IP address, or device fingerprint, or the third one is API key or token. So this is the solution for that. Now the fourth one is clock sync issue. Okay, so clock sync issue. Okay, this is very simple. Like client side, let's say the clock timing is 10 o'clock right now, and server side the timing is 10 o'clock and 2 seconds. Okay, so there is a lag between for the 2 second, and because of this user may get blocked too early, okay, or he can bypass the limit. So this is the problem with the clock syncing issue. So you should always rely on the server side timing and not on the client side timing. The fifth one is you don't have the fifth one. Okay, so only this 4 condition: race condition, distributed system issue, and then rate limit bypass, and then after that clock sync issue. Okay, now let's discuss about API gateway and load balancing difference. Why? Because here we are talking about API gateway, that the best way to design rate limit is on API gateway, right? So let's discuss what is the difference between API gateway and load balancer. Okay, so let's jump onto the theory part again. Okay, it is almost there, we are almost there. Okay, so this is the API gateway and load balancer. So I have already created one video on load balancer, if you remember. Okay, so here we will just see the API gateway new thing. Load balancer or load balancer is mainly about distributing incoming network traffic across multiple servers to ensure reliability and performance. You works on network layer 4 and application layer 7. Okay, now a router request based on simple rules like IP address, port number, system URL, okay, sometimes URL, ensure high availability and fault tolerance, does not usually modify request on enforce complex logic. So example, if you have 5 backend services, a load balancer is split request among them evenly. Now, what is API gateway? So API gateway sits in front of your API and acts as the smart entry point, okay, for clients. So key points works at the application layer, okay, layer 7, and then API specific logic like authentication, authorization, all that code you can move to API gateway. Instead of writing that in the separate microservices, just move that into the API gateway. Rate limiting, request response transformation, logging and monitoring, API versioning, routes request to appropriate microservices. This is also API gateway does. So now example is a mobile application calls one endpoint and API gateway authenticate the user first, then aggregate data from multiple services and return the single combined response. Okay, so request response transformation also he's doing. So these are the core differences. Okay, just go through this load balancer and API gateway. Now how they work together. So load balancer is spread traffic across multiple API gateway instances, and API gateway processes and route API request internally. Now advanced concept if you talk about, which is global versus user level rate limiting. Okay, so what is user level rate limiting? We have already seen that you can limit per user or API key or IP address. Okay, so for example, user A 100 requests per minute, user B 100 requests per minute. So use case, prevent spam by a single user. Fair usage, right, means I have given only 100 requests to each user, they cannot go beyond that. Now the real world is Instagram limiting likes and comments per user, right, and login attempts per user. So that is the real world example. Now global rate limiting is something which you apply on system itself, on application itself. So like limit for entire system. Example, total system can handle 10,000 requests per second. Okay, so use case, protect backend from overload and control infrastructure cost. So real world example, Amazon during flash sales or payment gateway TPS limits. Now what is the hard versus soft limit? Okay, so hard limit and soft limit. So hard limit is nothing but I'm saying that user can send 100 requests per second. So if he sent 101 request, first 100 will process fine, but at 100 first request, okay, system will block the request or return 429, which is too many request error code. So here the pros is a strong protection and easy to implement, but the cons is bad UX, sudden failure. User will see what happened suddenly, that why the request is failing. So now what is soft limit? Okay, so we were talking about soft limit. So if in soft limit, let's say you have a limit 100, so you will allow up to 120 with warning or delay. Okay, so what technique you will use here? So either you will add the latency, so slow down extra request instead of rejecting them. And example, first 100 request instant response. Okay, now for next 20 add 200 or 500 millisecond delay. So the effect is reduce system load and discourage abuse without breaking UX. Now queue request. So the second strategy is queue request. Okay, so just put extra request in a queue and process them gradually. So example, users send 110 requests, so 100 requests process immediately and 10 go to queue and process slowly. So smooth traffic spikes and prevent system overload, right? The third one is show warning. Inform user that they are nearing or exceeding the limit. So for example, you just send this kind of message in API response, rate limit exceeded, and slowing down request. Okay, so the effect, what will be the effect for this one? Encourage user to reduce usage and better developer user experience. Now, real world scenario, if you see, so Netflix may degrade quality instead of blocking. Okay, so if you are watching some video and your network bandwidth is not that much good, so he will just degrade the quality you were seeing in let's say 4K, and now he has degraded it to 360. Okay, so that is the real world scenario. And then API allow burst traffic with burst allowed. Okay, so now rate limiting with queue. Now you can introduce queue also with rate limiting. So now instead of rejecting, queue the request. We are not rejecting now any request. Okay, no data loss, but just queue the request. So request come, if limit exit, push to the queue, or process at the fixed rate. Like tools you will use Apache Kafka or RabbitMQ. Okay, so example is email sending system, payment processing, order placement during sale. What will be the benefit? No request loss. Okay, smooth traffic. And problem, increased latency, queue buildup risk. Adaptive rate limiting. So now next one is adaptive rate limiting, next topic. So adaptive rate limiting is AI based. Okay, so here dynamically adjust limits based on behavior. So for example, it will monitor traffic pattern. Okay, just monitor which kind of traffic he is getting, and error rate, and then CPU usage, and adjust limits automatically. So for example, for normal user, he's setting limit 100 requests per minute, and for suspicious user, he's setting limit 10 requests per minute, and for trusted system, he's setting limit 1000 requests per minute. Real world, like Google API or fraud detection system, we use this. Okay, so technique, which technique you will use here? Machine learning model and heuristics, rule based or behavior scoring. Now benefit, smarter than static limits, prevent abuse dynamically. Challenges, complexity of course, and false positive. Now what API gateway implementation, if you see here, so what you do, you just implement rate limiter in API gateway. Okay, like tool you can use nginx, Kong, or AWS API gateway. So why we are using gateway, so we have already discussed it, but here the few points like centralized control, scalability, security. Okay, and distributed system. So HTTP response, if you see code, HTTP code 429 is basically we use for the too many requests, and we send this request when the limit exit. Now let's discuss few important questions. Okay, so what is difference between throttling and rate limiting? See, rate limiting is defined maximum allow request per time window, like 100 requests per minute, and if exceeded, then reject or send the HTTP code 429. Now what is throttling? Control speed of request processing. Okay, instead of rejecting, slow down and then later just process that request. So real world example, if you see, so Instagram rate limiting and Netflix throttling. Now how implement rate limiting in distributed system? So how you can implement that? Using the using the Redis. Okay, so centralized counter, you will have the centralized counter, and you just identify the key, increment the counter in Redis. Okay, and then use TTL, time to expiry, time to leave, then reject if limit exceeded. How would you scale a rate limiter? See, how would you scale a rate limiter, or how would you scale a system for 1 million requests per second? Both are same, because the rate limiter is also based on the system request. So here you have few methods like sharding, we have already discussed. Okay, so instead of one Redis, use multiple Redis nodes. So second is consistent hashing. Okay, smart distribution, we have already talked about it in my earlier video. So here you use some hash function, let's say hash user ID mod 5, and it will give you server number, node number, and then it will distribute traffic request evenly on different servers. Now why consistent hashing is better? When a new node added, so only small portion of user shift and not full redistribution. Now local versus global hybrid. So see, every request hitting Redis is slow. So even if you have a centralized Redis system, but if you have multiple servers and every request is hitting Redis, then it will at the end will be slow. Okay, so in that case, what you do, in local memory, okay, in local memory, you just use the local counter for each server, okay, and then you update it, and over the period of time you update the Redis. Okay, so here first request will go to local memory, then Redis, and then decision. So example, local check allow if under limit, okay, and then final validation. So for example, if I have five servers, and I can allow 10 requests per second, so I will assign 2 values to each server. Okay, so they will check. If it is lesser than 2, then they will allow it. If it is greater than 2, then they will go to Redis and then sync the number of counters request, okay, or the counter value. Now use approximation. So approximation, here you can use Bloom filter. Okay, so Bloom filter is a data structure, memory efficient data structure actually. So see, you cannot track each and every request. You are getting 1 million requests per second. You cannot store those requests in database. Okay, it will take a memory, lots of memory. So solution is use probabilistic data structure. Bloom filter, okay, has this user exceeded limit. Let's say you have one scenario where you need to check user exceeded limit or not. Okay, I have given him maximum 5 login he can do in one day. Okay, wrong login he can enter, and that is what I need to check. Now I cannot go to database and store all the requests and check to those requests. Okay, so here I will use the Bloom filter. So instead of storing 1 million user counters, okay, use Bloom filter, memory efficient fast lookup. So small false positive possible, where use very high scale system pre-check before Redis. So what is a Bloom filter in rate limiting? See, a Bloom filter is a fast memory efficient data structure used to check whether an element is probably present in a set. Okay, in rate limiting, it helps us to quickly detect repeated or known requests without storing full data. So Bloom filter can tell you definitely not seen this before, or he can tell you maybe seen this before, and that could be the false positive also, but you don't need to go and look up the entire data. Okay, now just go through this document. Okay, I have pretty much covered everything, and these are just repeating on the, okay, so Redis cluster, distributed version of Redis. Instead of one Redis server, you can have multiple replica of Redis inside one cluster. Okay, auto sharding, replication, high availability, these are the feature for that. Example setup, like you have 6 nodes, 3 master and 3 replica. So now benefit is normal benefit, like fault tolerance, scalability, and no single bottleneck. And if you put all these together, so client will have load balancer. Okay, you have 3 different servers, server 1, 2, 3, which has the local load limiter, okay, rate limiter, and then all these three will go and attend this Redis cluster global rate limiter. Now Redis versus in-memory rate limiter. This is what I discussed you, that locally he will store the counter, and then later they will sync with the global one. How to handle burst traffic? So token bucket is best for that. Okay, leaky bucket also you can use, or queue based buffering also you can use. Using the soft limit also, okay, you can handle burst traffic. Burst traffic means suddenly you will get this spike request, lots of requests. How to avoid single point of failure? So you do Redis replication, okay, Redis cluster, create multi-node setup. Fallback mechanism also, if temporarily local rate limiting, okay, if Redis fails, then you should have one fallback mechanism for that. Multi-region deployment, deploy your application in multiple region. Okay, if one region fails, then he can go to different region. So now, how to rate limit globally across regions? So when your system runs in multiple regions like US, India, EU, enforcing a single global rate limit becomes tricky. Okay, so for example, you want limit equal to 100 requests per user globally, but your system is deployed in US server, India server, and EU server. So challenges data consistency, right? Each region sees only its own data. So then second one is latency, okay, because regions are far from each other. So the approaches is centralized global store, okay, just go through with this, and regional limit plus global sync, API gateway global control. So I have added a few like questions here regarding this, and this is the final pro tip. I would design in interview. You can say that I would design a distributed rate limiter using Redis with token bucket algorithm. You have different algorithms, so I'll choose here token bucket. Deploy it at API gateway. That is the best place. Okay, shard it for scalability, different replicas. Ensure high availability with Redis cluster. So now here I will create a cluster, and handle burst traffic using token bucket and queue. So rate limiting is not just about blocking user, it's about protecting your system while ensuring fair usage. So that's it. Thank you.